Hello friends, welcome back to the channel. It's Dennis Peter here again, and in our today's tutorial we are diving into something every developer and system administrator should know, that is NGINX. Whether you are running a small website or managing high traffic applications, NGINX is your go-to tool for performance, scalability and reliability. In this video I will explore with you the powerful features of NGINX, including reverse proxy, load balancing, caching, and compression. By the end of this tutorial, you will understand and know what these concepts mean and how they can be worked out in practice and how you can set them step by step in your own project. So get ready to supercharge your web servers, boost performance, and scale like someone who has been there for 100 years. Make sure you stick around, hit that like button, and let's get into it. So our today's tutorial, we will be working with eraser.io. I just thought that we could just have some visualizations, maybe you can just conceptualize what we will be dealing with today. So I just set up a simple workplace for NGINX. Now the foundation of how NGINX works is from the term reverse proxy. What do we mean with the reverse proxy? This is a technique whereby you configure, you have to configure something that is going to route request from client to the server. Okay, now maybe you can understand that one visually. If I just have these boxes here to symbolize some clients, let me just have them there. Let me just have them here. That is client 1. Client 2, client 3. Now this one is server 1, server 2, server 3. Let me just set it that way. Then now here in between these clients and these servers, we have our NGINX configured. We have our NGINX. It's termed as it can be known as it's pronounced as NGINX. That way. So between those two systems, we have our reverse proxy, which in our case is NGINX. Now this client forwards request here, then this client forwards also request there, and this client, these are just example of clients, they don't have to be real, forwards the request there. Now this reverse proxy will now determine where that request will go to which server. This one will also determine which server. This one will also forward to the necessary server. What is the best understanding of this? Think about a scenario. You go to a very big organization or maybe a company, and there's maybe someone you want to see. How do you now go and see that person? You don't just go direct to that person you want to go and see. So what happens is that you as a person you as a person, you as a person, what happened? You will pass through the reception. You'll pass through the reception. Then from the reception, these all mostly are oftenly ladies. I don't know why most receptionists are ladies. Men are there, but few. I don't know why. I don't know why they choose ladies. So let's say you as a person, you are going to meet this person. Okay, so you are going to meet this person. This person dwells in a particular organization. Maybe this person is in a certain organization. Maybe is a senior staff in a particular organization. But you as a person, you want to see this. You want to see. Let's say this one. Let's say this one is a manager. You want to see the manager. You cannot just go direct to the manager's office. You have first to pass through the receptionist, and this receptionist will now direct you to the necessary room. Let me just now direct you to the necessary room. So that's the cheapest way to understand how NGINX works as a reverse proxy. So you cannot go direct in a certain organization or in a certain company to go and see a particular manager. You can't just go directly. You have to pass through a receptionist who will direct you to the necessary office. Now that is now what works with NGINX. A request cannot just go directly to the server. It has to pass through a reverse proxy, which will now direct that request to the server. What is more important is that this technique or this scenario is very important in as far as security is concerned. There are so many advantages of having this system that way. Maybe we can just highlight them. And one of the advantage, number one is security. Of course, security through something we call SSL. First of all, it's SSL, TLS termination. Let me just expand it a little bit. SSL TLS termination. So that's one way of the security. Then there is what we call load balancing. Then there is caching. Then there is centralized routing. Then of course we have compression. Now, NGINX has benefits. Outlining any kind of a system, passing a system through a reverse proxy. There is so much benefits, and one of the benefits is security. That is through SSL TLS termination. Then there is load balancing, there is caching, there is centralized routing, and there is compression. Now, this SSL termination, this SSL termination actually is from maybe I can just have a text box here. This SSL termination is from SSL, which means secure socket layer. Sockets. Don't know why it's which means secure sockets layer. Now in modern, this SSL, was more traditional, no modern. In a modern world, we have TLS, which is the modern one. It's called transport. It means transport layer security. Now, if you have been working with maybe deploying your systems on Linux-based servers, you might have. If you are operating on AWS, these cloud platforms have done a lot of abstractions to what is happening behind. So you might not understand what is happening. They have already done they have done all of that automation. So you may not understand what is happening behind. But when now you are dealing with Linux-based servers, you understand that you have to configure something we call SSL certificates. SSL certificates. SSL certificates. SSL certificates. Now, the fact that they are called SSL certificates, these are certificates that allow us to secure web traffic by encrypting it. Now, the fact that they are called SSL certificates, it does not mean they use socket layer, secure socket layer. These are modern ones and they use transport layer security. It does not mean that they use secure socket layer, the fact that they are called SSL certificates. Now, how does our reverse proxy using NGINX give us benefits in TLS SSL termination? It is because of one thing. Now, instead of our backend or our servers to undo request by encryption or description, that one can be directly configured at the reverse proxy. So you can configure that one there so that we don't give our servers so much headache in encryption and the description. Okay. Now that is how we use SSL and that is how we use NGINX in SSL TLS termination. Now there's another one which is very important, and that one is load balancing. Load balancing is quite confusing with the reverse proxy. How is that one achievable? Now, if I let me just bring this one here. Let me just delete this one. Let me just delete that one. Let me just delete this. Let me just delete this. Let me just bring this one here. Let me just bring this one here. Let me just bring it let me just okay, let me just minimize the size, then I can just bring these ones here. This one can be deleted, and just to bring this one here, then I can bring this one here. Now let us look at load balancing. Now let me just come up with a typical diagram to illustrate that one. Now here I have a client, then from here I have NGINX, then I have server 1, let me just minimize. So here I have my client. So I have my NGINX there, then I have server 1, server 1, server 2. Then from here I can have maybe server 1, server 2, server 3. Now we have a request here. Then we have another request here. Now this request, let's see, then we have this that way. Now NGINX redistributes incoming requests to multiple backend servers to ensure high availability and high performance. Now it acts as an intelligent system. That is NGINX. Let me come here and say load balancing. So what it works is simple. It redistributes incoming requests across multiple backend servers to ensure various importance. Number one, I can just highlight this one. What does that one ensure? So load balancing. So load balancing avoids overloading a single server. Then improves performance and availability. Then the third one ensures fault tolerance. What does that one mean? So this client has these different servers, and then we have NGINX for configuring and doing load balancing. Now what happens? This request, when this one passes through load balancing, which for our case is NGINX, it redistributes across multiple backend servers. Now it has the duty to know whether this server here, whether is dead or is working. If it's dead, it cannot redistribute traffic here. It will distribute to different servers. So that's what I'm saying, that load balancing ensures number one, that we do not overload a single backend server. Number two, it ensures high performance and availability in a way that one server does not have to handle everything. Then it ensures fault tolerance. I think that one is much understood. Let's look at caching. And for caching, allow me to delete everything, because caching is a little bit, we'll have to check on many things. So caching, so I have caching here, caching. Now, how does NGINX control caching? What do you understand with caching? You can understand caching in this scenario. Think of this way. Think of caching like a photocopier machine. So instead of every time doing different copies, doing printing directly, you can just have a document that was printed, stored somewhere in a memory. So anytime you want maybe to print another document, you do not have to maybe send it again to the photocopier machine. Okay, so instead of doing that, so what you have to do is that instead of sending that document again to that machine already will detect any request to have that document maybe printed or copied. So it will, instead of getting a new document from the user, it will detect the document that has to be printed, and then it will put that document from a more efficient memory that is easily accessible. How can that one be illustrated? Think of this scenario. We have, let me just increase that way. we have our client here. Let me just undo that. We have our client here, our client 1. We have our client there. Now, this client has this server. That client has that server there. Now, just a minute. That client has that server. That client has that. Let me just minimize this. Let me just also minimize this. That way. So this client has this server here. I can just add the server there. Then of course there is our NGINX here. Now you find out that maybe this server, maybe this client was pulling, maybe let's say there is this request. Let's say there was that request. Now let's say we can just come here and say, now I can come here and say this is without caching. Now you find out that without caching, this client has to make a request to the server, but that, of course, that request has to pass through NGINX, which acts as a receptionist. Now this resource will be sent back to the client, but the request again has to pass through NGINX, the response. Now what will happen is that there is a response that has come from ear to ear. Okay, this response we can say has taken like this response has taken maybe 500 milliseconds. For that resource to be pulled from the server to the client has taken 500 milliseconds. Now, think of this scenario again. Let me just copy it again. Let me pull it that way. Let me copy everything that way. Let's say this client and this server, this client is trying to access some resource from the server. It has taken 500 milliseconds. Now think of a scenario whereby now we have our caching. Think of this scenario. We have our caching. I don't know what's happening. I don't know what is happening. Let me just do. Now this is with caching. This one is with caching. This now is with the caching. Now what happens is that this client wants, let's say now this was a system without caching, and this is a system now with caching. And let's say now we want the same resource with caching. So what will happen is that this NGINX will pull the resource from server to client. Okay, but before this resource has been gotten to the client, it will be stored in a temporary memory location, so that when this client will require the resource again, NGINX does not have to route it back again to the server. It will just pull from the temporary memory location, which is more easier and more accessible than from the server. So what will happen is that this client will try to access this resource from the server. What will happen? NGINX will try to check whether at that memory location whether the same resource is there. If that resource is not there, it will now forward the request to the server, which will respond with giving the resource. Now, before this resource has been given back to the client, it will first be stored and then sent to the client, so that when this client wants to get the same resource once again in another request, this NGINX will not have to forward that request to the server. So what it will do, it will just pull the resource and then send it back to the client. So let's say here we have here we have our memory there. We have our memory, and then we have that way. Now with that way, you will find out that now to get the same resource from the server, to get the same resource from the server to the client, the same process may take the same resource may take maybe 50 milliseconds. 50 milliseconds. So you can see how NGINX is so much effective. So instead of building very low performance systems, very slow systems, you can just utilize the power of NGINX to make everything much more easier. So let's see how we can how this flow of caching works. Let's remove this one because we are not interested with it. Now think of this one. We have this. Think of this. We have let's say a request has arrived here. Request arrives. Now from there we have in cache. Now this request has arrived here. When it arrives here, there's of course let's say from this to this. When it arrives here, there is a lot of questions that has to be answered in cache. So it has to be checked whether it is in cache. If yes it is in cache, there is that, there is this. Then we have of course this. So this is a request from. Now, if yes here, then of course we have no. Then from here, if yes, we serve from cache. Serve from cache. That is cache storage. Now this one becomes very fast. If no, what it will do, it will fetch from the backend. Fetch from the backend, store in cache, then serve the response. So that's how simply happens. So this one is our cache decision flow. So it simply passes through cache storage. Then from the cache storage, it goes to decision. Of course, that is now where decision comes from. So this is the typical workflow of maybe there was no cache in the storage. So it fetches from backend, then serve response. Serve response. Serve response. That way. Now, let's see our caching benefits. So we have different caching benefits here. Number one is you find out that when instead of fetching directly from the backend, when we fetch from the cache memory, there is 10 times faster response. Then of course we have reduced server load. Then you have better user experience. Then you have lower infrastructure cost. So you have to understand one thing in caching. I want to give two items here. I want to give an example of items. Maybe I can just write. What is cached more easier? Number one is HTML pages. Number two is CSS files. Then number three is JavaScript code. Then of course we have JSON. Then we have something like SVG. Now there is another group of guys here. Number one of that guy is called JPEG, PNG, then you have MP4. Now, one thing you have to understand is that NGINX works better with this group of items here. Works better with that group of items. It can still do this, but under very pure performance. This one becomes very hard, more so when we are working with something like MP4. It can work with the JPEG, but under very pure performance, because when it has to work with these things, there are issues like losing quality, things like that. You have to understand that when you are doing caching using NGINX, it works better with text data than with media. Have that one in mind. It works much better with the text data than in media. So with that, we have checked on SSL termination. We have checked on caching. We have also checked on reverse proxy. We have also checked on load balancing. Then there is of course centralized routing. If now we have this server, we have these clients here, these client guys here. If we have those clients and these clients here, then we have maybe our servers there. Then we have our servers here. You find out that we have our NGINX here. Now it gives us the benefit called centralized routing. So you can centralize your routing. Okay, so you can have all servers at a different location, then client at a different location. These servers do not have to be at the same location. They can be different locations, but configured using the same load balancer, using the same reverse proxy. This one gives us much more benefit of centralized routing, and that one simplifies working with our system. It becomes very easy to troubleshoot and to find out what is happening and what is good and what is not good with our system. So maybe something I have not touched on caching. Is let me delete these guys here. I have not touched on caching life cycle. So number one, in our caching life cycle, we have something like we have fresh. We have we have fresh. Then from this, let me just reduce the size. So from this I can just reduce the size that way. Then I can just copy it, paste it here, paste it there, and I can align it, make it more decent, align it there. Then of course I can just align it here. Now let me just copy them, all of them. Let me just bring it here, bring everything here. So there is now this fresh. From fresh it goes to valid. It becomes valid. Then from valid, this is data. This is a request. This is data. It goes to stale. Then from stale, this is data in our cache memory. Then from stale, it goes to expired. Now it's you that configures how you want your data to be, at what duration you want it to be expired. Now this one has approximately 0 minutes. 0 minutes that way. Now this one also has approximately 30 minutes. Let's say we had an expiry time of maybe 60 minutes. Then this one has approximately 50 minutes. Then this one has an approximately 60 minutes. 60 minutes. So this one is the caching life cycle. Caching life cycle. So you can now see how our NGINX is so much important. Apart from all of these functionalities that we have spoken of, it has also another functionality of maybe of dealing with static web servers. And you have to understand that for you to build a very powerful system, you have to make good use of these tools that we have. We have to make good use of these tools that we have. Also when it comes to load balancing, to enhance availability, things like that. But you have to understand that it is very essential when it comes to building systems. Now, for the things like load balancers and maybe reverse proxy, we have not gone deeper. It was just on the shallow level. But if you have to go deeper, you have to look on things like if you have to go deep on things like load balancers, you have to study stuff like round robin, list connections, IP hash, health check based, things like that. How to configure load balancers, not just through maybe theory based in a way. Now in our next tutorial, we'll be checking on how maybe we can configure that, how we can set up our NGINX on just a Linux based server. So load balancing helps you scale your application, stay online during high traffic, and avoid overloading any single server. Whether you are using NGINX or cloud solutions, it must have be there in any serious form of deployment. It must be there in any form of deployment. Whether you are using Azure, whether you are using AWS, it has to be there in any serious form of deployment. So enough of that for today. For the coming other tutorials, I'll be explaining on how we can maybe go deeper with this and how we can maybe use these ones on a practical format. So enough of that is said. You can subscribe to my YouTube channel and like and share and help me grow. Thank you.